Good morning, everyone. Welcome to Chemistry with Professor John Nguyen. For today lecture, I would like to show you chemical calculations, chemical reaction, and chemical calculations. Please keep in mind two things that we need to know. One is the balanced chemical reaction equations, and the second one is molar mass. Okay, and I'm going to show you right now. Okay. First of all, when you um, on the first module of the let me see if I can show you that. When you on um, the class page canvas on the first module, you see the period table of the elements, and the second one's the name of the ion. Those are really good handouts. Okay. Now, okay, the period table. Okay, on the period table, there are two numbers. You notice that the first one on the top, in this case, it's on the top, is the smaller numbers. The bottom is the larger numbers. Okay, remember the smaller number is called the atomic numbers. That tell you how many proton an atom has. The bottom number is the atomic mass. It tells you what the mass of the average atomic mass of an atoms, and that's in AMU. And if you do in mole, that will be rams per mole. Okay, so we're going to be using that larger numbers. Now let's see, I can go back. Here we go. Okay, so that's the atomic weight. That's the average. Okay, and that's the number I just showed you guys. That's going to be in AMU or ram per mole for each element. Okay. Now, 1 mole is defined as a lot of atoms or molecules called 6.022 times 10 to the 23rd power formula units or atoms if we working with elements, molecules if we working with compounds. All right. Okay. Now, one way to calculate the moles, the number of moles of a substance, is taking the mass, the given mass, divided by the atomic mass or molar mass. Okay. So what is molar mass, right? It's molar mass mean mass per mole. Okay. Moles mean that how many molecules or atoms. Now, for example, let's take a look at water. It's actually easier than you think. Okay. Let's take a look at water. Obviously, to figure out the molar mass, we need to know what the formula is. We need to know what the compound is. So let's say water. If we only um, working with one molecule of water, okay, that's very tiny. All right. We add up water is composed of two hydrogens and one oxygen. So we add two hydrogens plus one oxygen. Hydrogen is 1.01. Okay. Now again, we're looking at one molecules of water. Now back to the uh, periodic table. If you look at hydrogens right here, the mass is the larger number. In this case, they're almost the same. It's 1.01. Notice the atomic number is a whole number because it's the number of proton, but the average mass is um, not a whole number. It's a decimal numbers. Okay. Now, okay. So, and if you look at, so always have that period table handy. Hydrogen is 1.01 multiplied by 2 plus 1 oxygen, that's 16. So we got 18.02. Sorry, it's up here. 18.02 AMU, so that's per molecules. Okay. Now, if we do that for this, how many molecules? 6.022 10 to the 23 called 1 mole. Okay. If we do that, it's called a molar mass. And the molar mass is it's the same quantity, 18.02, the same way, except the unit is gram over mole or gram per mole. Okay, so gram. Gram is something we can work with. AMU, too small. Okay, so if you want 1 moles of water, you just use one of the balances and weigh 18.02 gram, and that's 1 moles of water. Okay, for water, if you remember density is about 1, so 18.02 gram is about 18.02 milliliters. Okay, all right, and you can convert that to ounces if you want to picture how much. So, as I just mentioned, the formula mass and molar mass are the same in quantity, only different in units. Again, formula mass is in AMU, that's only 1 molecule. Molar mass is the same numbers, 18.02 gram per mole, which contain a lot of molecules, and this is per mole right here. It's like a dozen is 12, a mole, it's a lot. It's Avogadro's numbers, 6.022, 10 to the 23 power. All right, so that's molar mass. Okay, atomic weight is for an element, an atom. Molar mass is for 1 mole of a compound. All right, now converting moles to gram and gram to moles. Okay, now this one I don't have the um, answer showing, but to calculate a mole, okay, one way is to take the mass, given mass, which is 2 gram, divided by the atomic mass, because this is single carbon, and 2 divided by 12.01, you have a calculator, you do that, that's the answer. Okay, now for water, I would like you to take a calculator to figure out how many moles. We just calculate molar mass of water, which is 18.02 right here, 18.02. So if you take 125 divided by 18.02, you will get the number of moles. Okay, so do that for me. Okay. All right, and then we'll discuss later in another video the answer for all this. Now, one way to figure out the grams of a given moles of a compound, in this case CO2, is to multiply the moles by molar mass, because molar mass is gram per mole over mole. So you cancel out a mole and you get grams. Okay. Now, if you do molar mass for CO2, 1 carbon is 12.01 plus 2 oxygens, that's 2 times 16, you should get 44.01. Again, that's 44.01. So take 1.29 mole multiplied by 44.01. You should get 56.8 if you round it off, 56.8 grams. Okay, again, 1.29 moles multiplied by 44.01, you should get 56.8 grams if we round it off to three significant figures. All right, see you guys in the next video, and we will get into the balancing equations and some chemical calculations. Okay, here they are. Thank you, and see you soon.